Two major components of Earth's climate system are the water cycle and ocean circulation. The joint US-Argentinian Aquarius Satélite de Aplicaciones Científicas mission can map the salinity or the concentration of dissolved salt at the ocean's surface. By measuring ocean salinity from space, Aquarius will provide new insights into how the massive natural exchange of fresh water between the ocean, atmosphere and sea ice influences ocean circulation, weather and climate. One of the oldest and most venerable satellite missions to date is LandSat. A NASA and US Geological Society project begun in 1972 with the launch of the first LandSat satellite, it is the longest-running contiguous Earth imaging program. The 8th of the series is currently in orbit.
It orbits over the North and South poles, taking imagery on the sunlit side of the Earth every time it passes.
The LandSat 8 satellite makes 14 orbits per day and covers the entire globe every 16 days.
The data from the LandSat data continuity mission will be the best data that have ever been collected from a LandSat satellite. With increasing population, our land use are changing at rates unprecedented in human history. To manage and cope with these changes, we need to have the observations, the information, the data that allow us to understand what's going on the surface of the Earth where most of us live.
The data collected over 40 years of the Earth's surface has created an historic archive unmatched in quality, detail and coverage.
LandSat archive that contains all of the US-held data from all of the LandSat satellites, and the LDCM data will become part of that archive.
The LandSat program offers, free to anyone, the longest global record of the Earth's surface, and it will continue to deliver visually stunning and scientifically valuable images of our planet. However, the Earth's surface is predominantly water. Measuring the topography of the oceans is another challenge altogether. Begun by the Topex Poseidon satellite, a joint effort of NASA and France's Centre National d'Études Spatiales, and continued by the Jason-1 satellite, their latest mission is Jason-2, continuing to provide a long-term survey of Earth's oceans. It measures changes in the height of the sea's surface. These are used to understand shifts in ocean currents as well as sea level rise, both critical parts of global climate change. The data is used around the world to improve weather, climate and ocean forecasts. Another ocean-going measurement is the speed and direction of the winds. The Sea Winds Scatterometer is a specialized microwave radar that measures near-surface wind. The scatterometer estimates wind speed and direction over the Earth's oceans at 10 meters above the surface of the water. The instrument collects data over ocean, land and ice in a continuous 1,800-kilometer wide band, making approximately 400,000 measurements and covering 90% of Earth's surface in one day. Earlier satellites could only image the uppermost layers of clouds. CloudSat was among the first satellites to study clouds on a global basis. It looked at their structure, composition and effects. The key observations are the vertical profiles of cloud liquid water and ice water contents and related cloud physical and radiative properties. CloudSat flies in tight formation with the Calypso satellite, carrying a backscattering LIDAR, and these two satellites follow behind the Aqua satellite in a somewhat looser formation.
When we started with airs on Aqua, we had two goals defined to us, before the mission started. One, provide data to the nation's weather forecasting center, which is NOAA, and improve weather forecasting. So that was the first goal achieved, and we, the science team, felt good. The second goal was improve our understanding of the climate system, the water vapor. That is the main mechanism by which weather and climate is formed here on Earth.
The combination of data from the 3 satellites provides a rich source of information that can be used to assess the role of clouds in both weather and climate.